What up, what up? On this video of Back to Basics, we're going to talk about solving systems of linear inequalities in two variables. Quite the mouthful, huh? It is. In a previous video, we talked about graphing linear inequalities on a coordinate plane. You know, that's the one where you graph the line, maybe you dash it, maybe you make it solid, maybe you shade above, maybe you shade below. Well, in this case, we're going to be doing that with two at a time. So there they are. There are two inequalities that I have to graph on the same coordinate plane. So that's two lines, two shadings. What does that mean? Well, when it was one inequality, when we would shade an area, okay, that meant all the coordinates, all the ordered pairs in that area were part of the solution. Now I'm going to have shading and then shading that covers shading. What does that mean? Well, simply put, when the two shadings meet is going to be your final answer. All right, so what we'll do is we'll graph both of those inequalities on the same coordinate plane. We'll shade once, we'll shade twice, and where the two shadings meet is going to be your answer. Some books like to call that double shaded area the feasible region, so I kind of like to mark it with an R. That way, if I was taking this on like paper and I used pencil and I had gray shading and more gray shading, the teacher would understand what my answer is if I put a big fat R on it. So speaking of big fat R, let's move my big fat face. It's not fat. Let's graph the top equation in red. I have y is less than negative or equal to, pardon me, negative x minus 2, which means we put the dot at negative 2 because that's my y-intercept. My slope is negative invisible 1, which means up 1 over 1, up 1 over 1. So up 1, left 1, up 1, left 1, up 1, left 1. More, and then more, and then more. And I can do down 1, right 1, down 1, right 1, down 1, right 1. Now is the weird part. I'm going to graph this and make the line solid. Why? Because that's less than or equal to, which means the line counts as part of my answer. Now I have to shade. Do I shade above the line or below the line? This is a less than or equal to, so I'm going to shade below the line, and I'm going to use this nice magenta color here. Yeah. Okay. Hopefully that translates well on YouTube. I'm going to graph this other guy in blue. I'm going to put a dot at 2 because that's my y-intercept. My slope is negative 5, which means up 5, left 1, up 5, up, don't have room, down 1, 2, 3, 4, 5, right 1, dot, and I can't go down 5, right 1 again, no matter. All I need is 2 points. I'm going to make a solid line because it's or equal to. Draw the line right there. Draw the line right there. And in this case, I care where everything is shaded above the line. Now, this is difficult to draw out when you have a very steep line like this. But what you have to realize is above the line were to be like, if this is a mountain, which side would you be climbing? You wouldn't be climbing this left side because you would be inside the mountain. You would be climbing this side right here because that would be above the line. Barely, but above the line. So let me try this again. Get a wrong thing. Get a highlighter. Let's make it blue. And I'm going to shade everything above the line. Now, what you see, and it's not that much, what you see is in this area right here, the purple and the blue meet. My answer, my solution to a system of linear inequalities is the shaded region where both shadings meet. So what I'm going to do is I'm just going to get one more pen. All right. I'm going to make it dark green, and I'm just going to really emphasize the fact that this is it right here. And I'm going to put an arrow there with a big R saying, that's the region. That's the region that I care about. So all of these points in here, and if the coordinate plane were to continue going on forever, that little triangle would go on forever too. All of these points in here, like 2, -6. If I were to plug 2, -6, or if I were to plug 1, -3 in, or all of these points way down here that you wouldn't be able to see, if I were to plug that into both inequalities, it would work for both inequalities. It would be a true statement. All right. So again, if I were to plug in 2, -6, and here, do all the math, I would get something true. Like -6 is less than or equal to 0, which is a true statement. And if I were to plug 2, -6 into here, I would get, what was it? What did I say? -6 is greater than or equal to -8, which is a true statement. It works for both. Now, if you're thinking, well, what about the part that's only blue or the part that's only purple? Well, the part that's only blue, like these guys, only work for my blue line. The part that's only purple would only work for the red line. So if I were to give you a question and say, if I were to plug in 3, 3, would it work for the red equation? Would it work for the blue equation? Would it work for, inequality? Would it work for the red inequality? Would it work for the blue inequality? Would it work for both inequalities, or would it work for neither inequality? Well, if I were to plug in 3, 3, it would only work for the blue inequality because it's only the blue part that's shaded. Okay, the double shading is my solution because it works for both inequalities at the same time. Let's see what else I got. Okay. I think I can move my face up there. We'll see. That's not the same one, is it? It is. Huh. Really wasn't thinking there. Okay. Looks like we're only doing 2 examples today. That's the same one? It's not the same one. The only difference, though, is it looks very similar. Oh, well. I noticed that this is not or equal to, so that might be the only difference, but whatever, we'll find out. I'm going to graph this top one in red. I'm going to put a dot at -2. My slope is negative invisible 1, so up 1, left 1, 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 down 1, right 1, down 1, right 1, down 1, right 1. That is just greater than, no, or equal to, so I'm going to make it a dashed line, so that's where it's different so far. Dashed line. It's greater than, so I'm going to shade above the line. And that's the red inequality. I got to do better at that. That's the red inequality. I'm going to graph this guy in green. I'm going to start at +2. My slope is -5, which means up 5, left 1, invisible 1, but I can't go up 5, left 1, just like the last problem. But I can go down 5, right 1, which is you. Can't do it again. That's less than, no equal to, so a dashed line. Bing! Every time my phone goes off, an angel gets its wings. Actually, I think that was my watch. I'm going to shade below that steep mountain. So remember in the previous problem, we shaded above. Now we're shading inside the mountain. So here's my green-ish. So that area that is both purple and green, that area right in here is my feasible region. That is the area where if I were to plug any of these points, as long as they're not on the line, because the lines don't count, if I were to plug in any of these coordinates into both equations, they'll work for both. Okay? Okay, now let's do that last one. So I see you are not solved for y. So let's solve you for y. So 4x plus y is less than 2. Is y all by itself? No. Subtract 4x from both sides. Subtract 4x from both sides. No flipping of the signs. I'm going to write it out so that it's in slope-intercept form. So the negative 4x comes first, and since that's positive 2, I'm going to add 2. So I'm going to graph that in black. Y is less than negative 4x plus 2, so there's my plus 2. I can go up 4 over 1. No, I can't. I can go down 1, 2, 3, 4, right 1. I can go down. No, I can't. So now I need to draw my line. Should I make it solid or should I make it dashed? Dashed. Door dashed. That is a less than sign. Should I shade below the mountain or above the mountain? How about below? Because it's less than, which means it's below the line. I'm gonna use this orange yet. Let's use this nifty orange. Yeah. Okay. Y is greater than negative 2. So in the previous video, we had like an X and no Y attached. And you might be thinking, how do I graph it if it doesn't have the X? Or well, how would I graph it if there wasn't a Y? It's either going to be a vertical or a horizontal line depending on the letter that you're given. The letter that we're given here is Y. So y equals, or in our case, y greater than means we're going to go to negative 2, there it is. And since this is greater than and not equal to, we're going to draw a horizontal dashed line. Because technically, I could write this out as y is greater than 0x, which means my slope is 0, which is a flat slope. And it's greater than negative 2, which means I shade above the line. So let me get my highlighter out, let me get blue, and let me draw or shade above the line. So we have this area right here where the orangish and the bluish meet. That's my feasible region. Which means if I were to plug in 0, 0, if I were to plug in negative 5, 2 into both equations, it will work for both equations. If I were to plug in 3, 3, it would work for the green equation, but not for the black equation. And if I were to plug in negative 6 or negative 5, negative 5, it would work for the black equation, but not the green. And if I were to plug in anything from this blank area, it would work for neither. And that is how you solve systems of linear inequalities in two variables. Bada bing! All right, thank you. Thank you for your attention and love. Bye!